All right, what do we know about absolute value? Liam, what do you know? Anything about absolute value? Nothing? Don't remember any of it. That's okay. Drew? It's always positive. Okay, absolute value is always positive. Anything else that we know? Jordan? Never make eye contact. Make eye contact. It signals that you want to answer a question. Okay, if there's a negative outside the absolute value, then it's going to be a negative. Okay, that's because that the absolute value is always positive, so that negative will make whatever that value is inside a negative. Very good. Anything else? Remember, absolute values represents the distance from zero. So, weird things happen now with absolute values and inequalities. Okay? So we just learned about these two fancy things called and or inequalities, right, AJ? Remember that? Yeah. And inequalities did what? Which way did they shade? Towards each other. So or shaded away from each other. And that's actually true with absolute values as well. Okay? So absolute value inequalities are either going to be an and inequality or inequality. And it's all dependent on, we're a little off, so it's all dependent on this symbol. Okay, so those symbols, notice it's the same thing here. This one says the absolute value of x is less than 2, and this one says the absolute value of x is greater than 2. So what makes one an and inequality and what makes one an or? Well, the one that's less than, when the absolute value is less than, that's going to be an and inequality. And when the absolute value is greater than, that's going to be an or inequality. But the thing just with absolute values, remember, you have to get it by itself. So if we go back to what Jordan was saying, that negative outside, we have to move that away from the absolute value in order to figure out what's actually going on. And remember now, when we divide or multiply by a negative, we're going to have to flip our signs. So we can't just say at the beginning, oh, this is going to be an and inequality. We have to make sure everything is away from it, and then we make that statement. Okay? So, oh boy. Let me align my board. All right, so let's look down here. It says solve the absolute value of x is less than 2. Okay, so what does that mean? How do I graph this? Why is it an and inequality? Okay, well, do you guys remember how to solve absolute value problems? What did we have to do? We had to break it apart, right? Do you guys remember that? You don't remember that? Oh boy. All right, so with absolute value inequalities, what we did was we broke it apart. And on the one side, we said x would be equal to 2, and on the other side, we said x would be equal to negative 2. Ring in any bells here?
Oh, yeah.
Okay. Now, because it's not an equal sign in there, basically what we need to do is we need to say x is less than 2. And over here, do you know how we would flip the sign? So this would be positive 2, and over here, it would be negative 2. Do you guys remember that a little bit, Destiny? No? You're like, Harmon, that was like a week ago. Like, I don't even remember what we did Thursday. I feel you. Thursday was yesterday. That's all you needed to know. Today is Friday the 13th, second one of the year. Last time we had a Friday the 13th, do you know what happened? The world shut down. So I don't know what today holds in store for us. but
Wait.
we're going to figure it out together.
Wait, not all.
Yeah, Mom.
Yeah.
Oh my God. I remember exactly what I did.
I don't.
Obviously not if you didn't know it was Friday the
I was
13th.
with you.
But you were not with me.
What did we do?
Oh
We
my
went to
God.
dinner.
Unreal. So Destiny, what we did was we would flip the sign of the 2. So it would be x equals 2 and x equals -2. Do you see how we would flip that sign? But now we have 2 signs. We have this sign and we have the sign of the number. So we have to flip both of them. Okay? All right, so we flip both signs. Now, AJ said, and inequalities shade towards each other, right? Let's watch what happens here. So don't do anything just yet. So we started with the absolute value of x is less than 2, right? So I'm going to put 0 in the middle. 1, 2, 3, 4, 5, 6. -1, -2, -3, -4. Over here, this says x is less than 2. So I go to 2, it gets an open circle. And I'm shading that one, right? Because that's less than. Here, I'm at x is greater than -2, so I go to -2. Okay, and greater than would be to the right, so we shade that one. Do you see how I'm shading between the 2 circles? So this is an and inequality. It behaves exactly like an and inequality. Jordan, you okay with that a little bit? I know, it's confusing. So here, okay, this one, it says the absolute value of x plus 7 is less than or equal to 2. Notice the absolute value is by itself, so I can make that statement that AJ was telling me about, that it's going to be an and inequality because the absolute value is less than, okay? See how the absolute value is by itself? So, and it's less than 2, so it's an and inequality. So what I'm going to do here, okay, Sophie, is I'm going to do x plus 7 is less than or equal to 2. You see that?
Yep.
Now, Andrew, at home, on the other side, I have to flip my sign, but I have 2 signs. I have the inequality sign and the sign of the number. So I have to flip them both. So I have x plus 7, okay, is greater than or equal to, notice I flip the sign, -2. All right, so let's do the left side in blue. So I subtract 7. So if x is less than or equal to -5. Let's do the right side in red. How do I get rid of the plus 7? I subtract it. So if x is greater than or equal to -9. So let's go with -11, -10, -9, -8, -7, -6, -5, -4, -3, -2, -1. Why did I start at -11? Well, I wanted both my numbers to be on my number line. So here we go. For this one, notice x is less than or equal to -5. I'm not eating the x. So it's going to be solid circle on -5. And since I'm not eating the x, I'm shading to the left. Now the red one. X is greater than or equal to -9. So it's a solid circle at -9. And I'm eating the x, so I'm shading to the right. Notice they overlap, and my answer is between my 2 dots. So that's why it's an and inequality. Starting to get it? Making a little bit of sense? Liam, feeling better about absolute value now? You're like, oh, I do remember that stuff, right? Who do you guys play tonight? Springfield? Oof. You guys got to beat them. Be like, it is unfair that you have a school that is so nice looking.
It's not that nice on the other side.
Yes.
It's not finished, Hope.
We walked in. The building we walked in.
Unreal, Hope.
The building on the other side of the street was
are they gonna do with their old building?
Tear it down?
Yeah, they've already started.
Just and turn it into what? They should turn the
Gravel
side into
field?
bleachers, because it just looks. I do not like their field at all. I'm sorry.
Man, this is gonna be on YouTube, and they are totally gonna hear it. And they're gonna be like, "Who's that Pope person?" We're gonna find her.
No, it's not. No, I like it. It's just like I feel like they
Her
need.
name is Hope.
No.
She's in Mr. Harmon's first period class. Okay, she sits in the back,
Yeah.
plays the sport. Okay, it may or may not be soccer.
It no. It's,
I hope Springfield hears this.
no,
All right, Hope.
No. I wasn't saying.
I'm gonna
I
tweet it
don't
out to
like
you.
it. I just think
Hope,
it's
here we go.
bleachers.
Let's solve C. Hope,
Okay.
do you see how the absolute value is by itself?
Yeah.
There's no other numbers outside it.
Yeah.
So we can make the conclusion that this is an and inequality because the absolute value is less than. Do you see that?
Yeah.
So I know I'm going to be shading towards each other like AJ told me. So here, I'm going to break it apart, and I have 2w minus 1 is less than or equal to 11. And on this side, I have to flip both signs. So 2w minus 1, flip my sign, and flip the sign of the 11. Mackenzie, you with me?
Yeah.
Awesome. Awesome. So Mackenzie, on the one on the left, 2w minus 1 is less than or equal to 11. What would your first step be?
To add 1.
Add 1. So I'm going to do that in green. So I'm going to add 1, and I get 2w is less than or equal to 12. Then what, Mackenzie?
Divide by 2.
Perfect. And I have w is less than or equal to 6. Let's go with, who else is at home that I should call on? Let's call him Matt. Matt,
Yeah.
Matt, what would you do first on the one in the left, or the right? The 2w minus 1 is greater than or equal to negative 11. What would your first step be?
Add 1.
Add 1. Notice, I kind of like doing absolute value problems. Do you see how the steps are the same here? So I'm going to add 1, and then my next step will be probably to divide by 2. Do you see that? It's kind of easy. So 2w is greater than or equal to negative 10. Then what, Matt?
Divide by 2.
Divide by 2. So w is greater than or equal to negative 5. So I'm going to come over here. Okay, I got to get 6 and negative 5 on the number line. So I'm just going to start with negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. Well, 6 is what it is. Okay, you could. All right, the only other thing you can do is put 0 in the middle, negative 5 to one side, 6 to the other side. But I don't think we're there yet. Okay, so the one on the left is green. It says w is less than or equal to 6. So I'm going to come out here. It's going to be a solid circle. And I'm shading this way. The one on the right, whose w is greater than or equal to negative 5. That's a solid circle. And I'm shading to the right. So I shade to the left for the 6 and to the right for the blue. Bada bing, bada boom. Cool student in the room. Okay. All right. Now, that was and inequalities, which means this is going to be an or inequality. Okay? So watch how we go about this. We still do it the same way. We have x is greater than 2, but when we flip both signs here, we have x, flip your sign, and flip the sign of the 2. So you have x is greater than 2 and x is less than negative 2. So I have 0, 1, 2, 3, 4, 5, 6, -1, -2, -3, -4. So here, let's go to the one on the left. X is greater than 2. So it's an open circle. X is greater than. We're shading to the right. X is less than -2. That's an open circle. And I'm shading to the left. Notice it behaves just like AJ told us, or inequalities shade left from each other. For a problem like E, same thing. X minus 1 is greater than or equal to 5. X minus 1 is less than or equal to -5. Notice I flipped the sign of both. So now I'm going to go ahead and add 1. X is greater than or equal to 6. Subtract 1 here. X is less than or equal to -6. Okay? Sound good? Now, here's the thing. This is what I don't like about these two problems here. Okay? Oh, your answer is not always going to be 2 and -2. Okay? This is just a weird example where that holds true. My answer is not going to be 6 and -6. Got it? So you have to solve both sides of the absolute value. What's up?
Why would you?
Oh, my bad. Add 1. Good thing. Thanks. If I was allowed to give out pieces of gum, I would give you a piece of gum. But I'm not. So instead, I'll give you an extra credit point. Gotta reward people for calling me out on my mistake on YouTube. Unreal. Just like Hope, Springfield's gonna hear that. And they're gonna be like, that dude is garbage.
Wait, why are we?
I was making fun of
I
that.
don't understand the difference between the and and the or.
Okay. Let's finish up this one. And then I'll go back and talk about that. So 0, 1, 2, 3, 4, 5, 6. Okay, and then we're going to have a closed circle here, and we're going to shade to the right here. -1, -2, -3, -4. Closed circle, and we're going to shade left. But my point is this, Drew. You have to solve both sides of the inequality. You can't just say one side is, oh, one side was 5, so the other side is -5. You can't do that. You actually have to solve them. So Sophie said, oh, I'm like the and or kind of tricked me up still, right? So you have two kind of like inequality symbols, right?
Yeah.
You have greater than or less than. Agreed? So with absolute value, because you break it apart, you have two equations that you have to solve, right? You always had two answers. Do you remember that now? Because you have two answers, you're going to have two inequalities. So the inequalities will either shade in like towards each other, or they shade away from each other. And as it turns out with absolute value inequalities, that when the absolute value is less than your number, okay, see how this is greater than? When it's less than, it's the and. And when it's greater than like this, it behaves like the or. Okay, so it's an or inequality. All right, so at the bottom, you guys have two problems. You have two problems, 1 and 2. Okay, be careful with number 2 because the absolute value is not by itself. 1's just like the ones we did. So see what you guys can do. Why have you guys here? Everybody has their purple book. Everybody got their purple book from yesterday. All right, for the sake of time, we're gonna get started. And now we only have what, like 3 minutes left? So here we go. With number 1, we break it apart because the absolute value is by itself. So we have y minus 3 is greater than 4. Then we have y minus 3. Flip your sign and flip your sign of the number. So now we add 3 on the left, and we have y is greater than 7. On the right-hand problem, we add 3, and we have y is less than -1. So from here, I'm going to go ahead. I'm going to do it the shorter way. I'm going to put 0 right here. I'm going to put -1 right there. I'm going to put 7 right there. Okay? So at -1, it's an open circle. I'm not eating the y. Okay? Notice y is less than, so I'm going to shade to the left. And for the one on the left, y is greater than 7, so it's going to be an open circle, and I shade to the right. So that's what number 1 looks like. All good? Good. Now, number 2, we didn't do any like this, but you still know how to do it. Remember, you have to get the absolute value by itself. So your first step is to subtract 10. That gives you 3 times the absolute value of 2x plus 5 is less than or equal to 27. Now, some people might be inclined to distribute that 3 inside. Don't do it. Divide by 3. That gives me the absolute value of 2x plus 5 is less than or equal to 9. And now I can break this apart. So 2x plus 5 is less than or equal to 9, and 2x plus 5 is greater than or equal to -9. So when I subtract 5, I get 2x is less than or equal to 4. Divide by 2. You get x is less than or equal to 2. So I have that one inequality. Over here, I subtract 5. You're going to get 2x is greater than or equal to -14. Divide by 2, and you get your other inequality of x is greater than or equal to -7. So I'm going to put -7 here, 0. Then I'm going to put like 2 here. Let me put the 0 here. So what I'm going to do to graph it, it's a closed circle at -7. I'm shading to the right because it's greater than. Here, x is less than or equal to 2, so it's a closed circle, and I shade that way. So notice it's an and inequality. All right.